So this function, because it has x squared plus y squared and it's equal to 1, that's an ellipse. And this part says in the x direction, take the square root of that and go plus or minus 3. In the y direction, plus or minus 4. And then draw an ellipse. There's the graphing part, and now change to polar coordinates. So for changing to polar coordinates, I'm going to be using that x is equal to r cosine of theta, and y is equal to r sine of theta. And substitute those in. And if you ever forget those formulas, you can just draw a right triangle with theta as the angle. This would be x and y and r. And then just go to the definition of sine and cosine to get these two formulas right here. So substitute those in and we'd have x squared, which is going to be r cosine of theta squared is divided by 9, plus, and then y becomes r sine of theta squared, and that one's divided by 16, and then equals a 1. And so we've got r squared cosine squared and then that one's over 9. We've got r squared sine squared, and that one's over 16. And well, there's an r squared in each one, so we could factor that out. And then with a 9 and a 16, we could get a common denominator, which is going to be a 9 times a 16, so 144. So r squared is going to be multiplied with, so this multiplied the top and the bottom by a 16, so that's going to be 16 cosine squared. With this one, multiply top and bottom by a 9, so that's going to be 9 sine squared. And then it's over a common denominator of 144. Now cosine squared plus sine squared is equal to 1, but we don't have an identity for 16 cosine squares and 9 sine squares. And then I could cross multiply. So it's going to be a 144 over 16 cosine squared plus 9 sine squared. So in polar form, there's an ellipse.